This meeting is being recorded.
Okay, in yesterday class, we discussed about NTP and network network address translation, network time protocol. Saishri, can you tell me what is NTP and why it is used?
We used NTP, which is network time protocol. If there is a mismatch in the timing of the sharing of the packet between the PC or switch to router, so there's a delay in the communication. To overcome that, we do the time synchronization. So we do that using the NTP. So from world clock, the stratum value is 1 from the original time source. So in each hop, the stratum value will be increased by 1, and so it will be so the hop from the world clock to the original source. So that's the stratum value.
Yeah, that is correct. So on the world clock, the stratum value will be 1, and when it gets increment towards the source, it will increment by +1. So if it shows stratum value 1, that means that's the original source where the time got generated. From there, the stratum value will be incremented by 1. That is correct. The next topic we discussed is about NAT, which is network address translation. Dilip, can you tell me why do we need NAT?
Like mapping the address by changing the IP packets.
Why do we need that? Why do we need to change the IP packets?
You said that in an example regarding about the private IP ranges, local network. That's that what.
Okay. Mahit, can you elaborate on that answer? Why do we need NAT?
Sorry, I am absent yesterday. I will didn't go through the call.
Okay, that's fine. Anyone else? Can we elaborate why do we use NAT?
Translation.
Okay. Go on.
Means like you said, outside of the network, if they can't connect, there need to be a translation for that one. So that we have to use the network address translation here.
What am I translating?
Private IP address to the public IP address over here if a user wants to access the internet.
Yeah, so we are translating the private IP range, which is local to the network, that cannot be reachable over the internet. So we translate that to a private IP range. That is one use case where we use network address translation. So we discussed about different types of NATs: source NAT, destination NAT, dynamic NAT, and NAT overload or PAD. Divya, can you tell me what is NAT overload?
In NAT overload, we allow multiple devices on a private network, to share single public address.
Yes, when we have multiple source entries and we wanted to use a single IP to reach the internet, because buying an public IP for each person will be expensive. That's why we will use one public IP. We will use the mapping of private IPs, all of them, using the source port that will be mapped to the one network private IP. So that is where we use NAT overload or PAD. Gopi Raju, can you tell me why do we use dynamic NAT?
Sorry, yesterday I absent.
Okay. Who else came yesterday? Maybe Monica. Can you tell me why do we use dynamic NAT?
It's used for mapping local address to a global address.
Well, that is also a regular NAT, right? Why do we use the dynamic NAT?
Whenever we have more devices on the internal network other than the public IP addresses.
Yeah, so when we have many number of internal devices and we cannot map all of them to one public IP, then we will create a pool. And from that pool, one IP address will be assigned to one private IP, right? So it is also kind of concept of using PAT, but you are having multiple NATed IPs in the group.
Yes.
So that is why we use the dynamic NAT, guys. What else we missed? We missed the destination NAT. Kanish, can you tell me why do we use destination NAT?
Yes. So like it's like connecting to the public IP. So translating the public IP to private IP, it's known as destination NAT.
Well, any IP, you mean to say translating public IP to private IP is called destination NAT? Is that a fair statement? Because that is also called as just NAT, right? But what is that use case?
So in the case of NAT, we translate private to public, right?
I think you are missing a keyword. You are missing a keyword called source or destination.
Source
destination
IP, yes.
NAT, we will translate the destination public IP to the destination private IP.
Private IP, yes.
In the source NAT, we will be translating the source.
Source private IP to public IP.
Okay, yeah. So that's what we discussed yesterday, guys. We discussed about NTP, the time protocol, and we discussed about the NAT. So today we're going to discuss about SNMP and Syslog, and we will discuss about the file transfer protocols. Let's start today's class. So let's start with SNMP. So SNMP, guys, SNMP stands for management protocol. So what is this management protocol, guys? So SNMP stands for Simple Network Management Protocol. So the name itself indicates that a network is managed to identify if there is any changes in the network or any alerts on the network devices, or to monitor the network devices. So we use SNMP to collect and organize that information about the network devices. Like it could be a router, it could be a switch, or it could be a server, or a PC or a printer. So we can monitor all of those devices from a centralized hub. For example, let's say you have a SNMP server. Let's say in your network, you have maybe PC, printer, switch, router, IoT, or let's say maybe like tablet. Okay, so let's say you have all of these devices in your network and you want to monitor of all of these devices. Monitor meaning like if there is like some interface went down on this, let's say some interface went down on this switch, or it has like high CPU, or its memory is like getting low, or the switch port went down, or for example, maybe the power supply went down on this device, or the fan speed is slow on this device. So every device, we as an engineer cannot monitor it. Like we can monitor it, but it's a manual monitoring. But using the SNMP server, this will send the messages to see the health of the device, and this one should be responding back. So this is like a centralized hub which is managing all of your devices. Let's say this PC is not responding to the health check. So what the SNMP server will do? It will send an email to your email that, hey, for example, PC1 is not responding to me, check it. So it can send an email to you. Or if you use a ticketing system, like for example, ServiceNow or any of the ticketing system, meaning like you will be every day working on the ticketing tool. So you will get a ticket saying that PC went down, and you as administrator sitting in your office, you have to make sure that PC is up and running. So this is like the monitoring platform that will enable to send an update to you when something is wrong on these devices. So SNMP is basically a network management protocol, which is used to manage and monitor the network devices. So SNMP again is a standard protocol, meaning like it is not Cisco proprietary. It is open standard. Any device supports it, like Dell, Arista, Aruba, Palo Alto, any vendor will support it. And for example, SNMP uses something called agent on the device that will be being managed, and the SNMP manager is typically a software application running on the computer. So let's talk about that. Okay. So in this example, let's take or it is also called as manager. Okay. And let's say switch or router. So this is also called as SNMP agent. In SNMP terms, whatever the network device that we are trying to monitor is called SNMP agent, and this is called SNMP server or manager. Okay. So in this case, what we're going to do is they both communicate using messages called PDUs, protocol data units. So the network devices are called SNMP agents, and the server which is managing them is called SNMP server or SNMP manager. So basically, let's see the messages between them. How does these two talk, and what are the type of messages between them? So initially, first the SNMP manager will send a GET request. And then the SNMP router will send GET response. And now next, this will send next request. And this will send back the next response. And then it will send the trap or inform message. What is this trap, guys? So for example, let's say this guy sent message, how is your CPU? This will send the response, my CPU is okay. How is your memory? My memory is okay. So that is the request and response packets. But let's say this one sent a request packet, and let's say the interface went down. For example, the switch connecting to a server, that interface went down. So that interface message will be sent as a trap to the SNMP server. So SNMP server receives the trap or information message that something went wrong on the device. Let me send a trap to the server. And whenever the trap is received by the manager knows that something is wrong on the device. So let me inform the administrator. In this case, you as a network engineer, you are responsible for logging to the switch, making sure that interface will be back up. Any questions till now? So SNMP manager will send the get request to the SNMP agent, which is to access the MIB. So what is MIB, guys? MIB is nothing but management information base. Management information base. So this will query, hey, how does your CPU look? So it will look into the MIB of the device and this one will respond back. So MIB is nothing but the information database that's on the network device. And the SNMP agent, in this case, will try to send the response back, whatever the request that is coming from the SNMP server. Okay, so there are three versions of SNMP: SNMP v1, SNMP v2, and SNMP v2c and SNMP v3. So let's talk about them. So SNMP v1 is depreciated, guys. It's no longer used. It is the original. It is the original version. It is not used anymore. It has limited security features because it is not end-to-end protected. So for example, if someone in the intruder, if they can capture the data here, they will automatically know the data. So SNMP version 1 is no longer used because it is not authenticated. So anyone can bring their SNMP server into your network. They can connect to the switches, and then they can act as your SNMP server, which can cause bad things because SNMP server can also shut down ports and unshut the ports. So SNMP version v1 is not password protected. So this is no longer used. And SNMP v2, which is reiterated with v2c. So it is an updated version of v1. It will add more features. For example, like, let's say, let's clear a few things here. So SNMP server, instead of sending each update one by one, for example, the link went down, or the high CPU, or there is a messages on the memory. Instead of sending one message at a time, SNMP v2c will have bulk updates. So it can combine all of the messages into one bulk update, and it can send directly to the SNMP server. That is one of the key improvement from version 1 to version 2c. And also in the version 2c, password is protected. So meaning SNMP server has to authenticate just like a normal user to get the data back from the devices. For example, if I want to make any change on the switch, I have to log into the switch, right? Similarly, SNMP server has to log into the device. It is something that will be more relevant because it is password protected. But it is not encrypted, meaning if someone captures the data, they can see the plain text and they can use that information to log into the SNMP server and change something. So SNMP version 2 is okay, but it is not completely secure. That's why SNMP. How will the SNMP server know that switch sent a trap? Because the SNMP server will send a GET request. Again, it sends a trap. So trap is nothing but a type of message. Whoever asked this question, you can automatically stop me and ask that question. You don't have to ask in the chat. you can directly ask directly in the meeting. Okay, so SNMP version 2.3 is more secure because it uses encryption and authentication to protect the SNMP information. Let's talk about encryption authentication, guys. So encryption means if you are from a security background, you should have already known the encryption. So let's say
one question, Ravi.
Yes, go ahead.
So what if the switch or router is down? Like if the switch or router doesn't send any response back to SNMP server, so what?
That means that it automatically know that the response is not kept coming, right? Then it will automatically send that to the administrator because it did not get any response back.
Okay. Yeah, thank you.
So let's say encryption, we are talking about encryption now. So let's say I have a clear text. I love CCNA. So let's say I have a message that I want to send from this machine to this machine. This is source. This is destination. So if someone capture the data in the middle while I'm sending the data, if someone capture that by sniffing that, they can read my message. But by doing the encryption technology, I can put an algorithm and I can change this data to something like that. So how can I convert this message to this message, guys? By using any algorithms or snippets or ciphers. So if you are learning more into CCNA security, you will learn how to convert from one to the other. There are also like random cipher generators like MD5 authentication, AES authentication. MD5 encryption or AES encryption. Based on that methodology, you can convert this data to this data so that if someone captures data in the middle, they cannot read the data. It is not usable. If you have the key to decrypt the data, then only you can understand the message. Just like having an unreadable format of the data. So SNMP version 3 uses that. If someone captures the data in the middle, no one can read it because it is end-to-end encrypted. Just like when you're doing a WhatsApp call, sometimes you would have seen a message that WhatsApp is end-to-end encrypted. That means that when you're doing a video call or something, no one in the middle can capture the data and see your video call data. Similarly, SNMP version 3 is encrypted, meaning that it is encrypted, that it is better secure. There are different SNMP tools, guys. Different vendors are out there. The major vendors are SolarWinds, Nagios, and also Zabbix. So these are the basic ones, meaning like it will show us what are the devices are down, what are the devices are up. So let's take a look on the real-time solution, how the SNMP server looks like. So let me stop share here and let me share the another screen.
Sir, I had a quick question. My name is Anurag, by the way.
Okay, shoot.
Sir, for maximum security, where do you think it is safe to locate the SNMP server in the network diagram? Where do you think is the most secure place or the most desirable place? Like,
so you want to secure the SNMP server?
yes.
That really depends on how your scaling of the network is. Let's say you are using the core distribution access layer. You will be connecting something on the internal where it will be connecting to your access layer, but it will be protected with the micro segmentation. But in networks, there are different kinds of zones: application zone, database zone, web zone, WAN zone. But in this case, SNMP server will be something like in a tools zone where you put all of your tools like SNMP, Syslog, or your file cards, data. You will put that in the tools zone, which will be accessible over across the internal network. So considering the zones as your network, you will put something on the tools zone or internal zone. That's how you will separate them.
Okay, got it, sir. Thank you.
No problem. So let me quickly share how does an SNMP server looks like. So this is how SNMP server looks like. And if you go to like maps, so you will see how the network is laid out. And if you see here, there is one device and it has problems. So you can go to that device and you can click on problems. It will show you interface link down, interface link down. Like that, you will get traps or problems on your machine. This is the SNMP server. And from here, as an administrator, I can log in and then see, okay, on this device, this is the host. And this interface went down. Let me log in and see why it went down. So like that, you will have real-time viewpoint on a device going down or an interface going down. That's how we will identify the problems in the network. Instead of you manually going to the device and then seeing what went down, SNMP server is like a centralized place where you can see what went down and how is your network. Okay, let me stop share that. Okay, any questions there? Yep, I think it's fairly clear. If you have any questions, you can ask. If not, I'm going to move to the next one. The next topic is Syslog. Syslog is a system log message. Basically, let's say you have a network device. Let's say you have a switch. And you have a router. I mean to say a Syslog server. So whenever you do something on the switch, or whenever there's a change on the switch, for example, maybe an interface, you log into the switch and then configure an interface, like configured an interface. Or let's say switch had a high memory, something like that. So there is a log message on the switch. And this switch as a device itself cannot store logs more than like 24 hours to 7 days. Depends on the buffer on the switch, depends on the memory of the buffer. So there is a memory allocation for logging the device. Let's say I, as an administrator, I want to see what happened, something in the network 10 days back. I don't have visibility on the network going back 10 days and then look into the logs on the switch because the buffer got full and it will be rewritten. For example, it's like going back in time and seeing the news. So you don't have the visibility going back in time and seeing what happened. For example, let's say you are in a network and something happened and your network went down. This happened on May 1st. A client came and asked, hey, I came to your network on May 1st and I tried to access a file, but I failed. Can you tell me why? So this is called root cause analysis, RCA. When something happened in the network, someone will ask you to find the root cause. What happened to the network? In that case, you need to have the log data to see what happened in the network. But because your system buffer is low, it cannot store the data more than 24 hours to 7 days. But you're asking something on the May 1st, which is 23 days before. So then what we will do is we will automatically forward all the logs to Syslog server. This can store the data up to 90 days, or if the memory is higher, it can go up to 6 months. So Syslog server is basically a database storing all of your network logs. It can store your data multiple days so that it can help in root cause analysis to see what happened in the previous time to identify. So it's like a standard protocol where it will be, your network devices will be transmitting event messages so that your centralized logging server can contain the data. Okay. So there are different types of messages, right? So let's talk about those different types of messages. So it could be an error message. Error message is something like, let's say you wanted to configure a device interface, but the interface is in a bad state. Okay, it's dropping packets. Or next type of message, system event, meaning like switch rebooted, or CPU is critical. So these are like system events. They are like security alerts. That is something that like maybe mid-range CPU. It is not critical, but it's still an alert. Like those kind of messages will be there. And something will be informational, like informational messages, like Ravi logged into the switch. So there are different types of messages, right? So these kind of messages will all be sent to Syslog server, and they will be categorized as different levels. So you can see error message or system event or security alert or informational messages. So there are different categories. You're still seeing my drawing, right? My whiteboard you're seeing, right? You're not seeing the screen, right?
Yes,
sir.
Okay, just making sure, because I see that I'm sharing something else. Sorry. Let's go back. Example, code severity description. Yeah, so there is a code level for each message. First thing is 0, and that is called emergency message. Like system is about to die, meaning like switch is about to die or router is about to die, like those kind of things. That is the emergency messages. Next thing is like code 1, that is like alert, meaning like action must be immediately taken. Like check the CPU or check the interface, like that. Next is what? Critical condition. For example, WAN interface went down, or packet loss. Like that. 3 errors, like cannot log in to the switch, like those kind of errors. Like warnings, like check your command that you typed is incorrect, or NTP server is not reachable. I mean, like that, a warning. Next thing is notice. Like normal, any messages like For example, what I can say, maybe like created VLAN or created interface, just like a normal message that you get on this on the device. So these are next is like informational, like switch version is this, boot version is this, anything like information that is, and the last thing is debug. Debug is like we doing the packet capture. When I wanted to see the data payload, like looking into the MAC address table, like those kind of messages, packet capturing, that kind of things will be discussed on the debug. So these are the 7 types of Syslog messages. It's purely for your examination purposes, but in the real time, you don't have to know what severity maps to what. It is just purely for your certification. They might ask you like, what is the code level for critical? So you need to map in the exam that the code level is 2. This is purely for your educational purposes, but nothing to do in the real time. You will not. You will use only the Syslog server to gather to gather the logs and then see what happened at what time. That's it. So, so that's about the Syslog. Let's talk about Syslog flow a little bit.
Can debug be considered informational message as well?
I'm sorry, your voice is like in a tunnel. I cannot hear the question properly.
Can debug be considered as an informational message as well?
No, it's a debug level message. It's not informational. It is something like if I wanted to know what is happening on the device, I will turn on the debug. In that case, the debug messages will show. That will be sent to the Syslog server as a debug message, but it is not as informational. No. Is that clear?
Yes, thank you.
Okay. So on the device, let's say there is a switch. If I wanted to send the logs to the specific server, what I'm going to do is I'm going to do logging enable, and then I will do logging host, and then define the Syslog IP. Okay, and I can define the logging trap. I can do like informational, or I can do logging trap, critical. So I can consider which message I want to send to this Syslog IP address, right? So I can if I put this command, I'm going to send only the critical logs to the Syslog server. So if I don't specify anything, it's going to forward all the logs, all the message types, the code level 0 to code level 7, whatever that we did, whatever we have, all the logs will be sent to the Syslog server. That's how we'll forward the logs. And so why do we use the use cases of Syslog are basically for security monitoring. So if there is any suspicious activity on the network, or if there's any data breaches, we can also identify what happened at a time. We can look into the Syslog messages. And while troubleshooting, as I said, when we are doing the root cause analysis, we can identify what happened, something in the past. To identify that, we use the Syslog message to identify that. And also if you are doing auditing, For example, if we wanted to identify how many interfaces are up, how many interfaces are down, are we using the SNMP, are we using the right level of configuration settings, something like that, you can also use Syslog for your audit purposes. So basically, Syslog is a simple protocol where you store your all the logs in a centralized database. You will forward the logs, and there are different levels of Syslog where you can forward the logs. Questions? Okay, we'll move on to the next topic, which is file transfer. So in CCNA concepts, there are two types of file transfers. So there are two protocols. One is FTP and FTP. So both are basically file transfer, meaning like if you have a specific file that you wanted to send that file from one machine to other machine, usually you will use a pen drive, or you will use a copy, CD disk, or you will use a floppy disk, something like that, where you will copy the data and then you will send that to the other device by connecting through the hardware, whatever NIC you have. But when you have two devices in the same network, this is a router 1, this is a router 2. And you wanted to send the data from this PC to other PC from here to here, you will use a protocol called TFTP or FTP. There are other protocols like SCP, SFTP, but that is not part of the CCNA syllabus. Let's look into the these two protocols. So let's talk about TFTP first. TFTP is nothing but trivial file transfer protocol. That's the full form. TFTP. So instead of you taking a pen drive, copying that here, and then taking that pen drive out, sending here, and then putting the pen drive here, and then sending the data, you can simply run a protocol to forward the data between them instead of manually doing this process. So in TFTP, basically, it's a simple protocol. TFTP is a simple protocol that is used to transfer the configuration files between two devices. But FTP is more advanced, and which is used to send the larger files. Like for example, maybe like a video that is like in gigabits, something like a big file, FTP is used. And if it's something like a small file, TFTP is used. And TFTP is not secure, meaning again, when I'm sending the data, if someone in the middle, if they can capture the data, they can read the content of the packet, and they can capture the data and they can reuse them. For example, let's say you have a file which is confidential on this machine, and if you use the TFTP, some intruder may capture the data and then they can see the content of the payload of the file, which is not recommended. That's why we use SFTP or SCP, which is encrypted. But the FTP is password protected, meaning when we have password, when we wanted to share the data between these two files, it is password protected and no one in the middle can get that password. But using the TFTP, even though you use a password, because of its plain text, someone can capture the data and they can know your password, which is not good enough. So TFTP is used basically for small files and with no security. Let's say you have a small file like a text file that you don't care whether someone in the middle can capture the data. You can use a TFTP and you can send the data using the TFTP protocol. And whereas the FTP, on the other hand, it is used to send the bigger files, and also it will be better secure with a username and password, which cannot be getting the data back because the password is protected. Okay, so let's take let's say you have a PC and you have an TFTP server. And you have another PC. So this is where, let's say this is like your database where you have all of your company data. So from this database, you will put that file on the TFTP server by placing the data on the TFTP server, and the PC1 will send the GET request to TFTP server, GET or PUT request, and this file can be downloaded directly to the PC1. So there are different applications that can do this kind of transfer. Okay, so let's say this PC1 needs an image and you want to download that image file directly from the database. So you'll upload that file from database to TFTP server, and TFTP server, you can push that to the PCs in your machine. From there, the PC will send the GET request, and the TFTP server will respond back with the file that it wants to send the data. That is how the TFTP works. Whereas FTP is a little different.
Can you repeat again, Ravi, please?
Sure. So let's say this is PC and it wants to download a file. It could be any file. And that file is in TFTP server. It will send the GET request to the TFTP server. TFTP server will respond back with the file. This sending the GET request and responding back is the TFTP protocol. So basically, when I meant the GET, it means that it is asking the server, I need a specific file. You will specify the file name, and the server will send the file back to you over the network link that you have. So this is not something that is done without network connectivity. So PC should be having the reachability to the TFTP server, and the TFTP server will send that file back. This is just like an application. Let's say you are on your PC, you want to go to google.com. So you will go to PC1 and then open a web browser and then go to google.com. You will send the HTTP GET request. You will get the response back. Similarly, for PC1, if you want a file, you will send the request to the TFTP server and you will get the data back. But here you are downloading a file, not just seeing the file. Make sense?
Yes, thank you.
Let's talk about the FTP then. Similar case. So you have a PC. And you have TFTP server, or sorry, FTP server. In this case, let's say you want to get a file, you will send the GET request, but you want to have bulk files. Let's say you have like 10 files. You will send 10 files list, and you will get bulk files in a single go, because FTP can handle larger transaction, unlike the TFTP. FTP can get bigger files, it can forward the data. So you will send the list command and you will get the response back. So in this protocol, you will use get request and also you will use list command. So all the files will be sent directly to you from the FTP server. So let me show you in the real time how I gonna get a data file from a device to the other device using the FTP server. Okay, give me 1 second. Let me set up that. Okay, it's ready. I'm going to share my screen. Let's see. Okay, let me create. So here I have a Linux box, and if I do ls, I see only one file here. So now I want to copy. Let's say on this machine I have. Let's say I have dpy.sa as my text file. I want to copy this file to that device. Okay, so I'm going to close this. I'm going to open the WinSCP, which is the file transfer protocol software. I'm going to open that. I can select the protocol that I want. I should be selecting the name of the server that I want to forward the file to. So that have to be this name, because this is the server I want to put the file on. So I'm going to put that there. My username and password. Continue. This is just asking for the two-factor authentication because it's set up like that. So I authenticated that. So now I'm connecting here. So now I want to move my file. So let me select the desktop. I wanted to move this file. So I'm gonna right click, or I can do simply. So I moved from here. I moved the file to here. So now let's log into the device and then through ls. So you see dpy.sa.txt file is here. So here in this case, I moved one file to the other file without using the pen drive, right? So this is how we use a protocol to connect between two devices. I mean to send a file between two devices. So that's how we use a software to send a data between two devices using a protocol called SCP, FTP, TFTP. Something different protocols are there, but you understand the idea. We are using a protocol to forward the data between two devices. Questions? Is that clear?
So both the devices should be in the same network, right?
Yes, they have to be reachable. Correct. They both have to be reachable. I mean, they don't have to be in the same network. For example, let's say you have a server in internet. Even though you have the internet reachability, you can still do the transfer. It's like downloading a movie from the internet to your laptop. So even though they are not in the same network, you are using a web browser to connect to that website. Let's say torrents. So you will log into the torrent site and you download the data. So even though you are not in the same network, you have a network connectivity. Similarly, if you have the network connectivity, you can forward the files. Yes.
Okay. Can you please open that application once?
That is WinSCP application.
Yeah.
WinSCP. That is the name of the application.
No. Can you show me the UI?
Yeah, I can. Yes.
So here in this case, the sender, like the device one can see all the files which are present in device two also, right?
No, this is the application seeing, but the device cannot see it. Because the application is running on one device, it can see the local files. On the left-hand side is the local files, right-hand side is the destination server.
Yeah, but the destination server is holding two files currently. Before
Yes.
before the destination server had only one file.
Yes. I copied the file from source to destination. Yes.
Okay. Yeah, understood.
Yeah.
So the files
It
which
can
you
work both
copied
ways.
will be seen, right?
Yeah, it can work both ways. I can copy the image from here to here as well. For example, let's say I want to put this file from here to documents. Okay, so I'm going to change this to my documents. So here, this file is not there, right? So I can directly move it here. So if I go to documents, let me go to documents. 1 second. It's a big jump server. I have to do. So if I go to documents, you see this file dpi.sa, it is still there. So that's how we can do the file transfer in both sides, not only one side.
Okay. Thank you.
Okay, let me stop share quickly. Okay, so that's pretty much. So let's have a quick summary. So we discussed about the first topic we discussed is SNMP. So SNMP is an network management protocol, simple network management protocol that is used to monitor the data, monitor the devices, and whenever there is something change in the network, SNMP will alert the administrator or user something changed, and we have to make sure that we have to alert, we have to get the alert, and we have to act accordingly. Correct? So SNMP has different versions: SNMP V1, V2, C, and V3. V3 is popular. It is better secure, and it uses encryption technologies. SNMP V2C is also used, but it is not as much as secure as V3 because it is not encrypted end-to-end. SNMP V1 is no longer used. No one will use it. You will not see in the real time in any company because it's depreciated like 10 years back. And Syslog is like a server where it's collecting all the logs of the devices. It's like a database holding the data. So there are different levels of Syslog, starting from critical to all the way to debugging. There are different levels of it, and you have to remember the codes of each. That's because to pass the CCNA. In that exam, you will get question 1 or 2 like that in your CCNA exam. But the concept is very simple. You have a database of logs where you can use it for troubleshooting, error handling, or you will use Syslog to go back in time and then see what happened for the root cause analysis. Last thing is TFTP or FTP, which is the file transfer protocols, which is used to transfer the file between 2 devices in your network, or which has a reachability. TFTP is a simple protocol, but it cannot handle large file data transfers, whereas FTP, on the other hand, is it can handle bigger files, but FTP is also better secure than TFTP. And FTP doesn't have authentication, I mean encryption, guys. FTP cannot do the encryption, but it is a password protected. So that's why we use SFTP, which is secure FTP. That will be encrypted end to end, but that is not covered in CCNA. The next thing is to use SFTP. But yeah, that's a summary of the class. Any questions on these 3 topics? I see a couple of new guys joined today. Are you guys able to follow the class, or do you feel that you are not understanding the concepts?
We are able to understand that, sir. Thank you so much.
Yes, sir. A little bit.
I'm able to understand as well. I need to go through the previous videos as well.
Okay. Yeah, I mean, these concepts are separate from the previous class concepts because these are individual topics. So I'm sure that is not a dependent topic. But if we talk something like, maybe in the next class, if I talk something like a DNS, some things might be missed from the previous classes. So it's better to go through those 15 recordings before and try to catch up as much as we can. And coming to the test, guys, put your emails in the spreadsheet. I think some of the emails are already there. So if you don't have your email on the spreadsheet, please put your email on the spreadsheet and get ready for the test over the weekend. I will share the batch questions tomorrow once I have all of your emails. I'm sure some of the people are not coming to the classes. I'm not sure why. I asked Kevin about that. He said people are in the graduation ceremony, and they will be joining from this week, but I still don't see the count. So I'm not sure how we can prioritize one batch over the other. I'll talk to Kevin about that. I think that's an off topic from this class. But please try to put your emails on the spreadsheet. If you don't know where the spreadsheet is, I'll post that again, that link. So please update your name and email in that spreadsheet and get ready for the exam, what we're gonna do for this week. Okay.
Yes, sir. Thank you.
Okay, that's all, guys. If you don't have any questions, you're free to drop, but I'm going to leave the floor for questions for 3 or 4 minutes from now.
Ravi, I just have one question. So in Syslog, you said there are like logs, so like code and everything. So for each code, so for example, I remember there's code 1 for alert. So it is just for alert, the code is 1, or is just like random?
No, for alert, the code is 1. Like emergency, the code is 0, alert is 1, critical is 2. This is just to identify the Syslog server that this is a critical log.
Okay, so yeah, they have like each code, right?
Yes,
For,
everything is predetermined by the vendor. I mean, to say industry standard, it is not something that changes per device, or that is you as administrator decided. It is a proprietary number that is given to each log.
Okay, got it. Yeah, thank you.
No problem. All right, guys, looks like there are no questions. I'll let you go. Bye. Good night. Take care.
Thank you.